3D, we're going to learn how to compare distributions. Okay, so look at two different sets of data that are related to each other and compare them to each other. So if we are comparing distributions of quantitative data, remember that's numerical data, we're going to make side by side, or sometimes you might see them called parallel box plots. Okay, so for this, we're going to follow the same directions as a single box plot or box and whisker. Those are the same thing. But you're going to highlight all the columns of data instead of just one. Okay, so I'm going to pull up the cup flip spreadsheet that we used earlier, and we're going to make side-by-side box and whisker graphs for cup flip and cup drop. So before we would just highlight like cup flip. This time I'm going to highlight cup flip and cup drop. So I'm going to drag from A to B so that it highlights both of them. And then it's the same steps that we did before. So insert, remember our box and whisker is in this little blue chart option. And you see it makes two box and whiskers, one for each game. And I'm still going to change this to the clear boxes so that we can clearly see the median. All right. And then I'm going to give this a title, and instead of like calling it cup flip or cup drop, since it has both of them, I'm going to call it cup games. All right. And that would be how we would make a box and whisker. And then we would use these two box and whiskers to compare cup flip to cup drop. And that comparison is going to look a lot like our description from 3B. So we're going to describe the shape for each distribution. All right, so for, you would say for cup flip, I'm going to say, I mean, that's pretty symmetric, maybe slightly skewed right. This side of the box is a little bit larger. Um, and then for cup drop, I would say the same thing. I would probably call this symmetric. I know that side of the box is a little bit larger, but to call it skewed, we want it to be really obvious. So I would probably say both cup flip and cup drop are symmetric. Okay. Then we're going to describe the center, all right, for each distribution. Again, your options are mean or median, but if we're looking at a graph, it's most likely going to be median. So we're going to give the median and we're going to compare the two medians. All right, so the median for cup flip, if I click on the chart and then hover, the median for cup flip is 4 because the median is that box that goes through the middle. And the median for cup drop is 6.5. So what I would say is the median for cup drop is 6.5, which is higher than the median for cup flip, which is 4. So you're going to have to write a sentence here and compare the two. Tell me what the numbers are and tell me which one is greater or less. Okay, we're going to do the same thing for variability, either range or standard deviation, most likely going to be range, and compare them. Okay, so I can see here that cup flip, that looks like it goes from 9, I think that number's 9 to 1. So cup flip would have a range of 8, and then cup drop is going to go from 11 to 1 as well. So that's going to have a range of 10. So again, I would say the range of cup drop is 10, which is greater than the range of cup flip, which is 8. Okay, and then we would still do our outliers like normal. Show the math for your 1.5 times IQR rule. I'm okay if you screenshot a Desmos page, but you need to make sure that it shows all of them. All of your calculations, so IQR and the two cutoffs, the one for low and the one for high. If there are outliers, you need to say what those outliers are. Don't just say, yes, there are outliers. What are the actual numbers that are outliers? Okay. Then we can also compare distributions of categorical data. Okay, so this is, remember, our non-numeric data. Here are the steps on how to make what's called a segmented bar graph, all right, where we put the two things together. So here's the data we're going to use as an example. We have how many people participate in each activity, and we split it apart by gender to try and see if there's a difference between boys and girls. Okay, so we're going to put this data into Excel. Okay, so that's what I've done here. I just copied that chart exactly as it appeared. We do want to make sure we have titles for each of our columns, all right, that describes what's in there. And then I'm going to highlight all of this data. I'm going to go to Insert. All right, we're going to be in the chart menu like we were for our bar graphs and dot plots. And this time, we're going to pick the percent stacked. Okay, so look, these two look very similar. If you hover over it, it says 100% stacked column. That's the one we want. All right. Now, depending on how Excel organizes the data, we really only want to compare boys and girls here. So I'm going to hit this button that says switch row column so that I only have two charts, one for boys, one for girls, and then it has the different percentage that chose each activity. Okay, so that's how we make the chart. And then as always, we're going to give it a title. So I'm going to call this activity by gender. Okay. Then you can't do things like mean, median, range, all of those for categorical data. So the question that we're looking to answer here is there an association between the two variables? So in this case, the two variables we were looking at was the activity that people picked and then their gender. So is there an association? Is there a difference in activities that are picked based on the different genders? Okay, and so what we're looking at is do our two bars that show the different percentages, do they look the same or do they look different? Okay, so here's my bar chart. I can clearly see differences in these graphs. A much larger percentage of boys chose soccer, whereas a much larger percentage of girls chose drama club. Okay, so when there is a difference between the two bars, we say there is an association between the two variables. Okay, the gender of the person does change the percentage of people that picked each activity. Okay, if these bars were mostly the same, so like each color was pretty much the same on each bar, then we would say there is not an association between the two variables. Right, and that is it for 3D.